One, two, three, four.
Kia ora, my name is Erin Stroud and I am the host of our Starting in Science series here at SIS. Today I'm joined by a very exciting panel to talk about talking. Science communication and the role of scientists in society has been a hot topic lately, but are we doing enough to make sure that the conversation includes everyone? I think we all know that communication is an exchange. It requires engagement and active listening, as well as sharing of perspectives, ideas, and information. So my question is, how can scientists do better at both sides of the equation? So speaking of scientists, I'm going to get our panel to introduce themselves now, letting us know who they are, how they became interested in science communication, and what role it's also played in their careers. So Emma, would you like to kick us off today?
Yep, absolutely. Thank you, Erin. So I am Emma Timewell. I'm the Communications Manager at Plant and Food Research. I have been a science communicator for more than 20 years. So I have a molecular biology degree and I am an absolutely rubbish lab scientist. It took me a long time to realize that the thing that made me a good cook made me a bad molecular biologist. So I came out with my degree and decided not to do a PhD and was looking for something else to do and got into communications, PR specifically, working for a what they call a full service life sciences communications agency in London. So working specifically with drug discovery companies who need to build profile to get funding and collaborations with pharmaceutical companies and things like that. So I did that for 5 years before I came to New Zealand. And then since I've been in New Zealand, 17 years now, I've worked with a startup biotech company. I worked at the University of Auckland and I've been at Plant and Food for the last 13 years. So I have spent most of my life talking about other people's science.
You're also an excellent mentor and role model for people at Plant and Food who are budding in their science communication careers, I must say. Thank you for your support. Brent, how did you get into science comms?
How did I get into science comms? Well, actually, I don't see it as being much different from what my day job is as a scientist. I think they're intimately connected. We do science and then we have to communicate what we've done. So it is an integral part of what you do. Sometimes I see some very successful and highly skilled scientists and they seem to forget to tell people what they've done. And I think telling people why you did something, what you found and what it means is hugely important. So I don't see it being as anything different from my day job as a principal scientist with Plant and Food.
That's very cool. And you've got quite a varied role as a scientist, don't you, Brent?
Yes. Look, I'm a soil, water and environmental scientist with a focus on primarily horticultural systems. Just finished a 4-year project in Kenya and Africa. They have current projects in the Middle East, and I have worked quite extensively in the Pacific. So, and that's a lot of communication involved in that. And currently, I'm also the president of the Royal Society to Apārangi, which again involves a lot of communication with a wide range of stakeholder entities within the Royal Society to Apārangi, within which, of course, sits the Science Media Centre.
So you'll be a wealth of knowledge for us to tap into today. Thanks for joining us. How about you, Maree?
Yeah, kia ora, Erin, and thanks for having me here. I am a little bit similar to starting out actually as Emma. I didn't realise that. We have something in common. We've both worked in the pharmaceutical industry, and that's where I started out an interest in science communication. And basically, I was in sales. So I was selling pharmaceuticals to GPs and to specialists and various other medical professionals. And I was then called into the University of Auckland to lecture on the newly established science communication course in 1992. And I must have done all right because I eventually took over that course, redesigned it several times according to the changes in science communication over the years. And then I added a couple of courses to that. And I ended up adding in science innovation and also science engagement. And that's now become the Science and Society module at the University of Auckland. And it's taught to over 1,000 students a year. And I'm also a researcher, being a social scientist at the university and a lecturer. I'm a researcher, and I co-lead the Mobilising for Action theme of the Ngā Takitaki program of the Biological Heritage National Science Challenge. That's a long mouthful. But what we do is we engage in the human dimensions of forest health. And science communication is not only an outcome of what we do, but also we engage in several outputs that focus on communicating out what we're doing a lot more widely.
Wow. Another expert in the field. We're very spoilt for choice today, aren't we? Brian, would you like to round us out with the introduction of how you got into science comms and what role it has in your career?
Yeah, sure, Erin. I feel like it's pretty special to sit here with people with such credentials in SciComm. I'm a research associate at Plant and Food, and I sort of split time between Ruakura in Hamilton and Brisbane in Australia. And I suppose my involvement with SciComm was sort of accidental. I guess like Brent, I felt like it's sort of inherent in how I think about my role. I did a master's degree in entomology, and the person I studied under was a very effective communicator. And I guess he sort of instilled that value in my science upbringing and was doing so many talks and things that we worked together on presenting our ideas to the general population. And yeah, so I really enjoyed that. I got into photography and have really enjoyed using sort of visual arts as a tool to facilitate communication. And in my current role, I think particularly working a lot in Australia, where a lot of the horticulture industries we work with are sort of new to plant and food and new to thinking about pollination, which is sort of where my horticulture and entomology cross in the pollination space. And so there's been a real emphasis on communicating our findings to those industries, particularly in Australia, through various channels. So yeah, I've sort of gained an experience on the run that way, and it's a part of my job that I've really embraced. So.
Well, it's not only great to have such a experienced panel, but also picking up a very passionate panel as well. So I'm sure we'll have some cool conversations going ahead today. I guess going back to one of the first points that I made in the intro, I talked about how science communication and all communication is really a two-part series, isn't it? We need the listening and the engagement and the co-innovation and co-design aspect, but also the communicating and sharing of ideas back to the people who, the research was meant for in the first place. So if we're thinking about that first side of the conversation to begin with, how can scientists begin to better engage with the people or the groups or the industries that we're actually meant to be serving in the first place? Maree, do you mind if I shuttle that question your way first?
Yeah, sure. It depends always how broadly you think of science communication. So do you see science communication in quite a linear way, in which you do the research and then you communicate it, or do you see it as a really interactive way? And I always see it as very interactive and very much about engagement. And so as a result, I believe that scientists can better engage if they actually develop in themselves a mindset to do that. So it comes down to the actual mindset that we create. And those have certain competencies and certain things that you need to be a science communicator, and a good one. The first one is disciplinary expertise, and scientists are full of it, right? That's what they're so good at. But it needs much more than that. It also needs you to be interdisciplinary. And that means to be open to other perspectives and other views on things and other ways that people might see. And in an Aotearoa perspective, that means to be open particularly to Te Ao Māori perspectives as well, and Mataranga Māori. We also need cultural reflexivity. And that, again, is about recognising those different perspectives, and as I say, within a New Zealand perspective. The ability to translate complex issues is absolutely important, but that also requires us to work collaboratively. So you need to be able to work across fields and with people And you also need to be able to have excellent communication skills, and everyone's been talking about that. Okay, so fundamentally, of course, you need that. But that's not just being a great speaker. It also means collaborating, and it means co-designing, and it means co-innovating, and it means dialogue. You talked about the two-way process. And the last thing I think you need is a reflexivity on your own values. And that means looking at things like issues of equity, social justice, ethics, responsibility. Those are all key things that you need in science communication if you look at it in a very broad sense.
No, absolutely. I'm 100% with you on that. I think engaging with groups that need to be engaged with is going to be a multifaceted approach, isn't it? And it is very much a two-way street. Brent, with your many hats that you wear, has engaging with different groups been a particular focus of yours in your career?
Oh, very much so, Erin. And just following on from what Maree said too, I agree. I mean, our work and where we're working across cultural divides, our work in Africa, our work in the Middle East, and in particular our work with Maori in New Zealand, it's very, very important as one of the prime goals for engagement and communication is active listening. It's actually understanding what other people are saying and going through a mutual learning process. In particular, in working with Maori, we use the concept of a potama, a staircase. You start together at the bottom of the staircase, and through active listening and moving forward and mutual learnings, you move up the staircase together. And it's a rewarding process so that you actually possibly you arrive at the top of the staircase with a common purpose and an agreed goal. If we possibly go back to bygone eras, I think the mantra of scientists will say, I've found this, you better do that. And no, that's not how things work now.
Oh, absolutely. Emma, you are someone who has to often engage with different industries. Do you use a similar approach for those sort of more industry-based connections?
I guess my role is slightly different in that I'm selling other people's science. So I'm not helping them design what they do. I'm very much at the end of the process. I'm actually at the beginning and the end. I tell everybody what we're starting, and then I tell everybody what we found at the end. I think it's kind of a spectrum. I think when you're doing applied science, like Maree and Brent and Brian are all involved in, I think that co-design is really obvious. I mean, if you're going to do some science for a particular purpose, then it has to be fit for that purpose. I think scientists who work in a lab at the more fundamental end find it a lot harder to understand why they should be communicating, because that's sort of it's a step back from the people that it will eventually help. And I occasionally talk to scientists who are sort of, I don't really understand how this fits, or people aren't going to be interested. And it's like, if you don't understand how your science can be eventually used, even if it's 30, 40, 50 years down the track, there's probably something a little wrong with your science. There should be a purpose to it, not just finding the knowledge, but the knowledge itself should have a purpose. So I think yes, there's a spectrum in that sort of two-way communication. I think it's harder for a fundamental scientist to take on board what might be needed, because nobody really understands what might be needed, but they definitely need to be telling people that they're doing stuff so that their science can move through those stages and inform other science and eventually get to the pointy end where it's really making a big difference in everybody's lives, not just in their little discipline.
Yeah, as someone who is working in that fundamental science space myself, I often have to remind myself to look at the bigger picture and remember exactly why we're doing this research in the first place. And there is always a why. It's just remembering what that why is can sometimes be a little bit tricky. Brian, as someone who is actively working in the space to create solutions for an industry. How have you found that sort of co-innovation or co-design of research?
I guess like most things in life, it's both challenging and rewarding, and perhaps rewarding because it can be so challenging. I mean, we're sort of talking about fundamental science versus applied science. I can see that it's sort of easier to see directly when you're doing an applied project in the field. I think it's sort of an overarching theme in science that we're good as scientists at finding sort of new bits of information, but not necessarily at understanding how it could or should be applied. And I think that's sort of a space where it's really important that we're communicating both in terms of quite narrowly saying, what's the challenge? You know, in my world, what's the pollination problem we're having and how we're going to fix it? But also getting that sort of cultural feedback, I suppose, about whether or not that's something we should be doing. So on a very high level, there's sort of this social license element to that communication. And quite narrowly, there's making sure I'm answering the question that the grower wants answered. Often those initial conversations, I go in with an idea that I want to go, and either because I don't understand the full complexity of that growing system, or I just don't understand what the growers want. And then there's this sort of back and forth to try to narrow in on a happy medium that works for both of us.
I'm interested in just this division between dividing of fundamental versus applied. And I think it's a bit of when it comes to communication, a bit of a false binary that goes on here. I think innovation, if we think of it as innovation rather than think of whether you're doing applied or fundamental science, innovation is fundamentally about change. It is seeking change, and that is technological change, social change, economic change, cultural change, and institutional change. And it doesn't matter who we are in that team, we are involved in delivering that change, in creating that change. So it's absolutely important that we're around the table, all of us, and that we're connecting. Yes, some might have the role, some may have the role to be the communicator of things and to translate and things like that. But the person in the lab who's doing the RNAi on, preventing fruit rot or something like that and using RNAi to do that, I mean, they are fundamentally engaged in really potentially controversial issues, potentially issues that will impact people's lives. And so as a result of that, it's important everyone's around the table and sees themselves as a part of that table, whether you're in the lab or whether you're at the flats roots level, of doing the science out in the field. So I see that as being that split between them is not an important one for science communication. Everybody's got to be around the table. That's part of the team.
I completely agree with that. One of my favorite things to remind myself is that no good science is done in isolation. And we really do need to view science and innovation as a team effort, really, isn't it? And different people are going to be good at different parts of that. It's just making sure that everyone not only has a seat at the table, but has the potential to talk at the table too, I suppose. So thinking about all of your sort of connections in other areas, Brent, like Kenya and other places that you've mentioned, how do scientists go about making those partnerships with different groups?
Understanding what the local problems are, and then not adopting the stance of I'm a scientist, I'm here to help, actually understanding what the issues are and working with them to work out how things can change for the better. I sort of, if you want a conversation killer at a party, I'm a scientist and it's not a good one, but I'm trying to work to improve fruit production, or I'm trying to improve water quality. That's something tangible and that's something understood. I'm trying to understand how to make better use of water resources for irrigation. And so that's a hook. The conversation begins on equal terms. And I think that's the beginning. And once you've got that hook, I think that the conversation can progress to how you might use, as Maree was saying, some fairly sophisticated stuff. I'm an applied scientist, but we use some pretty sophisticated kit and some pretty sophisticated analyses to get where we're going. Now, the partners that we're working with don't really care about that. It's just our stock and trade. We're working for a greater good, and it's working for their greater good.
And I guess a natural follow-up to that question, which I'll just open to the floor, following making up those partnerships, how do we establish those ongoing and maybe mutually beneficial relationships outside of the realm of our just lab teams and science?
Science, someone mentioned, and I can't remember who, but your science is a team sport. And what's very interesting, through my job, I also supervise a lot of students, and maybe like Maree, is that I find those relationships are enduring. Our work in the Middle East has involved 2 PhDs through me at Massey University here in New Zealand, and those relationships are enduring. And so as people's careers advance, it's marvelous to see that continuity and see them working on a wide range of problems well beyond what they did for their PhDs.
That's one of the things that really drives, I guess, categorizing things. And there's a number of things that drive different scientists. Some people it's just pure curiosity. Some people it's a desire to help. It's usually a blend of these things. And I sort of accidentally switched. Like I was an entomologist, just infatuated with biodiversity and learning about that. And the fact that I was working in agriculture was just sort of that's where my job was. And then I got to know these growers that I worked on their farms year after year. And farming is hard. I guess you could see the ups and downs. You can hear it in their voice when they're concerned about their crop. And it just made me wish, gosh, I wish I knew more about that particular problem. I wish I could solve this. And it became this really personal connection where I felt like my skills we help each other. I can't do the research I'm interested in without working with those growers. And over time, it actually became friendships. Like there's growers that will send me text messages about their cat and things. And there's a very personal level to it. I think at the end of the day, we're a social species. And there's a lot of that involved in the driver for many of us.
And that's really interesting what everyone's been saying about, it is about relationships. It's completely about relationships, creating, maintaining and sustaining relationships. And I suppose those relationships are so important because we've talked about scientists want to make the world a better place. Okay, that's often a thing they'll talk about, make a difference. But who decides what makes a difference? Who decides what is better? And so that requires that relationship because, you look at an area like, say, pest control, pretty straightforward. You'd think, yes, everyone in New Zealand wants New Zealand to be pest-free. You get that. But actually, it's not actually the outcome that everyone is particularly disagrees with. It's how you're going to get there. That is the challenge. So a lot of people will disagree with the processes that might be used to achieve that. And that's why relationships are so incredibly important. And in those relationships is building capability and capacity within the people that you work with. It's building that capability so that when your funding goes and when you walk away from this, and sometimes those friendships will be lasting and it's very hard to walk away, but many times the funding goes and you go somewhere else. Does your work still exist when you leave? Do you make that difference that you've put enough capability in the communities in which you work that they can sustain the learnings and the knowledge that's been created? That's, to me, one of the key things that comes out of good relationships.
Oh, I feel inspired to go out and do some cool research now to go back to the community. I think what we're kind of landing on is that science really needs to serve something. There needs to be a purpose to science for it to be meaningful. And it's cool that as scientists, we're at that place where we can actually go out and engage with the people that maybe could benefit from some of the science. And on top of that, we can also benefit from learning from the people that we're trying to help or serve in the first place anyway. One of my favorite quotes is from a person called Sir Mark Walport, who is this chief scientific advisor for the United Kingdom government. And he said, science isn't finished until it's communicated. And I could not agree with that more. And I think this is something Brent's picked up on before. So if we've spoken about listening, the active listening side of the communication that scientists need to be engaging in. The other part of that is obviously the sharing of ideas and information. So speaking to that, I'd be interested to hear your perspectives on what the role of scientists and science is in society. Emma, could you kick us off with that one? Sorry, it's a very big question.
It is a very big question. I mean, for me, it's the most important one. It's why I have a job, let's be honest, is helping scientists find a way to talk about what they do and why they do it. And that's interesting in itself, because scientists who want to publish are often very fixated on methodology and not so fixated on the discussion at the end of their paper, which of course is the bit that everyone outside of the science realm is interested in. You know, what did you find and how is it useful, and what's next? Not how did you find it. As Brent said, it's not how you do it. We don't really care what bit of machinery you did and how many times you ran the experiment. We want to know what the answer was and what do we do with that. So that's always an interesting conundrum, I think, for scientists to get their heads around, that what they're publishing in their scientific journals is the exact opposite of what they need to be communicating outside of science. I think it's really important that the science gets out there. I mean, we seem to be at a point, and as I was preparing for this, I was looking up how much actors and sports people earn, because those seem to be the people that are idolized these days. And if you think about a few hundred years ago, you know, everybody knows Newton's name. Even everyone knows Einstein's name. These people were rock stars in their day. And then rock stars happened. And it all went horribly wrong, I think, for science from that point on, because there was a point in history, or there's been probably for millennia, you know, scientists were telling people how the world worked, and now we're much more interested in entertainment. So I was looking up numbers. The highest paid actor was Daniel Craig, who earned $100 million last year. The highest paid sports person was Conor McGregor, who earned $180 million last year. The Endeavour Fund is $60 million. And so I just look at that and go, it's kind of ridiculous that we're trying to run a whole science system with less money than one person earns for being entertaining. And so whilst we're in a strange spot where scientists have not thought it's their role to communicate for so long, that it's a skill that has been left behind, but is actually more important than ever, because people are craving information and craving entertainment. And if you can tell your information in an entertaining way, then people will suck it up. And so wouldn't it be amazing if in 10 years' time, the highest paid person in the world was a scientist?
I'd be into that.
Not a sports person. A mixed martial arts sports person is the highest paid person, you know. And I'm not talking about Elon Musk and people like that, because we know that Elon Musk basically earns the same as small country turnover every second. But yeah, there just seems to be a very big imbalance, I think, in the world right now, where everyone's complaining that there's these big problems that need to be solved, but are then turning around and watching a movie star and watching weddings and yeah.
I do get kicked in the head less frequently than he does, which is
one benefit.
One benefit, yeah.
Brent, did you have something to add to that?
Yeah, look, well, actually, Emma's comment about high-paid people and then Brian's comment about getting kicked in the head. I spend quite a bit of time in the Environment Court as an expert witness, so I deal with lawyers and I suffer cross-examination where they're trying to kick me in the head. But actually, the whole basis of our legal system around the Environment Court and resource consent is around communication. It's about communicating the evidence base in an adversarial way around seeking resource consents to make a a good decision. It's a very constrained form of communication, but it's a very vital form of communication that we as scientists often get involved with. I find it rewarding in a certain sense. Under cross-examination, it's 99% boredom and 1% terror, but it's something that we should, as scientists, get engaged with so we can have just environmental outcomes in my case, but of course the same thing will apply around health and mental well-being and other issues like that. So there's another avenue where people can consider science as a form of communication.
I bet you're not the highest paid person in that room.
No, that's the point. But I'm the one that gets kicked in the head.
Maree.
Yeah, I just wanted to add something that I think the pandemics taught us quite a lot, actually, about science communication. And both scientists have looked very good in that, and also, I think, look very limited in it, if you see a broad view of science communication. So at the very beginning, we needed lots of good information. We needed good translation. We needed to know what the virus was. We needed to know about exponential growth, or I think we needed to know about it. And we got presented with models. I'm sure I felt by the end we had more modelers in New Zealand than we have sheep. But nonetheless, we had very good science communication. When the pandemic turned a little and we started, it was going on for a long time, and it's still been going on, and people started to tire from it. And when the vaccine rollout came out, we entered complexity. This is not just about science. This is about science in society, and it became complex. And then scientists who felt that all you need to do is communicate your information really well and people will agree with you, looked very wanting in that space. And they used the model of both the knowledge deficit model, that if you disagree, if you show resistance, that's ignorance. Now, while in some small cases that may be the case, in many cases resistance was brought about by many, many other reasons other than they didn't have good science information given to them. So it's about this really broad spectrum idea of understanding. To be a science communicator in society is that, you've got to be a good translator, you've got to be good at communicating, but you've also got to understand complexity and be relevant to that complexity and be at pace and know how to work in that. And that isn't always about just giving good messages.
Yeah, I guess speaking to that idea of giving good messages, how can we make sure that the information that we're creating as scientists gets back to the people that it was meant to get to in the first place, meant to serve in the first place? Brian, did you want to kick us off there?
Yeah, it certainly takes forethought. It's something that, we are actively studying. Plant and Food, for example, employs a number of people who are like Emma specialists in the communication itself, as well as social scientists, and people like Maree who are actually studying the science of studying how we communicate our science. And Maree will be able to comment more on that, but it does seem like that's even in the last 3 years. The projects that we have, usually there's a built-in element of actually measuring. We call it monitoring and evaluation. So measuring the impact that we've had on our specified target audience, if you will. So we actually spend a bit of time before a project even starts thinking about who are the people that we are working with on this, and what are the sort of indicators that would suggest that we've been successful in both doing the research and then communicating in a way that it becomes applied. So yeah, we spend a fair bit of time on that. And it circles back to that back and forth communication. It's been an interesting process in Australia where I'm running a very small project, but it's with pollination of a Australian endemic crop that's mostly grown by Aboriginal communities. And about halfway through the program, I got the feedback that the resources you've developed to communicate these results are great, except for they're all quite heavily English language. And there are 250 Aboriginal languages, mostly spread across the region where this crop is grown. So I've been working with people from Emma's team to try to figure out, okay, how do we take this, it's not a super complex idea, but how do we make this into something that's not dependent on a person's background in terms of interpreting it. So yeah, it's a moving feast in terms of figuring out how best to do that, and it does involve that back and forth.
I think it's really easy and also really dangerous to just think about who you're communicating with as the person or people who might need to know what you're doing. Yeah, if you start a science project, you can say, okay, this is my hypothesis. The results of this hypothesis will be of interest to these people. It might be other scientists in the field. It might be a particular set of growers, whatever it might be. But if we take Maree's point of it being it's sort of a team effort, everybody needs to know. You don't know who might need to know. And everybody needs to know different parts of it for different reasons. So yes, a grower might need to know how to pollinate their crops, but a grower of a different crop might need to know because they might be doing something that impacts that. Or people need to know because you need to keep getting funded or they need to buy the fruit, or there's lots of different reasons why people need to understand what's being done. And I think it's very easy to say, I am a scientist, I work in this field for this purpose. And the ones that want to communicate only communicate to that purpose and do not see it as their role to communicate beyond that. We talk about, I call myself a science communicator because I communicate science, but every scientist should be communicating their science. They shouldn't have to think of themselves as a science communicator. It's just part of their job, and they should be communicating that to everybody. And that's one, I think, flaw in our science system, not just here, but probably around the world, is that funding doesn't go into that. It's not a requirement of a scientist role. It's not something scientists are measured on. So they kind of go, oh, this is my added extra. The communicating is the added extra. I haven't got time for it. I don't want to learn how to do it. It's just not part of my job. So why would I? And that is frustrating for me because everything's so exciting. Like I work in a place with 700 odd people doing really exciting things. And some of them are really good at telling others what they do. And some of them just want to be left alone to do their thing. And I just want all 700 of them to be my rock stars.
I was just going to add to that because I mean, a lot of scientists will think that the end point lies in the publication and you get it in the journal and that's fine. And so they're happy. That's their output, is the publication. That's what they're measured on is often that publication that goes down in your things that you report back on all the time. In the Mobilising for Action theme that I co-lead, we actually say, yep, we want your publications, definitely. But we also say there has to be other outputs as well that are communication outputs. So we produce story maps, we produce films, we produce blogs, we participate in community forums, and we are actively engaged all the time in those spaces. Along with that, because many of our projects are co-design projects, because the people are part of the process. So therefore, they let you know immediately. You don't have to wait to the end to be told because they're round the table to begin with. Not always all the time. It would be a very big table. But at different stages in the process, there will be people, certainly at the beginning, and then brought in again at different stages and maybe added to. So there's lots of different things you can do to actually ensure that, that what you're doing is getting to the right people.
Following on from what Maree said there, look, as scientists, we do publish papers, and that's one way we communicate. But in a way, that's quite a private thing, and it's not really sort of communication. What I find is exciting is speaking to 60 farmers at the Huranui Rugby Club in Colverdon on a project you've done. It was called Post-Quake Kaikoura, about options for land use there. That's really exciting. These people hang on every word you say, and they want to quiz you continuously, and you break for afternoon tea and they still keep coming at you. It's absolutely superb.
You often get a different set of questions that you've heard before as well, don't you?
Yeah. Or you don't want to hear.
But I mean, when I worked at the university, there's always a string of public lectures, and there's public lectures around a theme. There's public lectures when you get your professorship, all these kinds of things. And they're very research based. They're graphs and charts and lots of jargon, and it's such a waste in some ways. Like if imagine public lecture series being booked out because you knew somebody was going to get up and tell you something that would have some kind of impact on your life, maybe not directly, but would make you think about something a little bit differently or do something a little bit differently. That would be amazing.
Yeah.
I have high hopes.
I was going to interrupt and say, why don't you put around the table an artist? Why don't you put around the table, I'm bringing arts-based practices into a lot of the work that we do. And I'm now joining up with education, people from education and people from the creative arts and industries. And so we're reaching communities through other ways, through like art practices. I mean, we're talking about developing video games for children to be able to, and actually even for adults. So there are really different ways, but you need to have those methodologies and those people who bring those methodologies in your team to begin with. Do you put them around the table at Plant and Food and put them around there and say, yeah, we've got artists as part of our team?
I was just going to say, in terms of artists there, Maree, there's a huge role for artists and how we communicate. You mentioned about an exponential. Look, my undergraduate's in mathematics, and I know what an exponential function is, and I know that the general public doesn't, despite their off use of the word. So how we develop infographics that actually tell them what the consequences of something that is undergoing exponential growth looks like, not just say y equals e to the x, is probably a good way of communicating it. So I just add to that, Emma, too, that I was up at Expo in Dubai with Plant and Food in February, and Plant and Food took its exhibition called From Our Land. Is that what it's called?
From This Land. Yeah.
From This Land. And Warabulo, one of our photographers, has photographed the work that we're doing in Vietnam on an aid project there. And it's a superb way of communicating via Wara's photos of people who were impacted by the benefits of the research that Plant and Food was carrying out in Vietnam. It had a huge impact.
I think those visual media forms to communicate research is super important. I'll lodge this question to the group. Is this what the future of science comms will look like? Is this how we bring inclusivity and equity into the science comms space, by making sure that we're getting artists on board, but also different types of science communicators as well?
Look, I can have a bit of a go at that. In fact, there is a convergence going on here, Erin. Another role I have is I'm an editor-in-chief on an Elsevier journal, and they are now encouraging not just an abstract, but an interactive graphic as an abstract to the paper. So they're saying, you do all the stuff on the paper, but could you give us an interactive graphic that someone can look at and visually see the story that you're trying to tell on the paper? So even the dry as dust scientific publication format is possibly getting into the 21st century.
There's a role that scientists and science training, I guess, has to play in this, in that scientists have to be able to tell their story. Because if somebody can't tell me what they're doing in a way that I understand, and I'm a science communicator with a science background, then how are they going to tell somebody else? It's my job to try and find a way to understand what people around Plant and Food do. And if I can't understand it, then I worry about how that is communicated further. And so I think scientists need to recognize that it's part of their role and want to learn those skills, because you can throw as many artists as a scientist as you like, but if they can't understand what the scientist is saying, then it's almost a waste of time.
That's fine, Emma. I get that, but that's not enough. Okay, it's just not enough.
No,
because the person, they can understand all you like, but if they don't benefit from it. Now, Brian was talking earlier about the relationship with farmers and how important that is. It's so critically important. That will actually get you probably making more difference by building that relationship than it will by getting them to understand whether they understand your words that you say or your messages or something like that. It's fundamentally important that when we go out to communities, when we work with Māori communities, that Māori communities benefit and gain the benefit from that research and participate and are at the table. And in fact, I mean, I had farmers who often said to me from projects that I've looked at and researched, and they've often said, oh, we just rent a farmer here. We just rent a farmer. And they'll often say, why am I not paid at the same thing around the table as others are when I'm contributing as much in this project? So there's some real fundamental things here about who does benefit. Do we share the benefits? Do we share the funding pool? And do those people genuinely sit around the table? I mean, Brian can probably speak to that more, because you were speaking how important that was for you and the work you do with farmers.
It's definitely a critical part of that, is having growers understand what the benefit is. I think I would say that the field days that I do, that's often the message that I start off with, in that I think pollination in particular can be a hidden problem. You know, if a tree is sick with a pest, the farmer can walk up and see that tree is sick, and it's quite an obvious problem. Whereas the pollination problem occurs during flowering or even prior to flowering, and then 4 months later at harvest, it manifests. So helping growers understand, developing sort of visual aids that say, we know that there's a potential deficit there, making it clear that this is what you have to gain, that, it's 5% of your crop that you're never even going to see. It's not going to fall off the tree. It's never going to appear in the first place. And sort of, driving home the value that those sorts of changes can bring. The other thing that this conversation is sort of making me think of is the thinking of communication in the broadest sense incorporates education. And we've sort of danced around it, and I'm thinking about social media platforms as well. It's had a big role in just putting that stuff out there that's really cool. There's so many bits about what we do that are just, the stories are amazing. It blows people's mind. I think that humans are innately interested in that stuff. We're all hungry for information in that way. It's part of what makes us what we are. But putting that information out there in a way that people engage, and it just sort of incrementally upgrades the science literacy of the whole world, which sort of makes the other end of that targeted stakeholder communication easier, because they've already got this sort of interest in general information about the processes of science and the state of knowledge. So that's been a fun and something I see changing. I was thinking about, I don't know if anyone's familiar with iNaturalist, but in terms of Erin's question about inclusivity, it's this platform where, I use it all the time. I'm a quote unquote expert, but I see stuff all the time. I don't know what it is. And I snap a photo, and 10 seconds later, it's up on the web and for everyone to see. And there's a community of experts who will say, that's this species, or even this subspecies, and here's why. And then there's a whole bunch of what we call sort of enthusiasts, people who are experts, but they don't have a degree in science, so they're not employed in science. And those people are also learning. And now there's this whole community of people that may or not be working in science, but they have this information that they can share. And I just find that sort of, social media is a double-edged sword, but that sort of thing where there's just this sort of universal accessibility of that information is really quite exciting to me. I don't know if iNaturalist exists outside of biology, but I hope so. It's quite cool.
Yeah, I've been on that I started in mycology, and I put up some photos being like, oh, look what I found. And I got absolutely schooled by a citizen scientist who corrected everything that I'd put up. And I learned a lot from that person that day. So I'm a big fan of iNaturalist. Cool.
Actually, you raise an interesting point there, Brian and Erin, around social media and the amount of misinformation and disinformation that is circulating there, and how we have a citizen's duty to actually make sure that correct information is available and disinformation is called out.
Yeah, and maybe that's going to be the challenge of the future of science comms.
Exactly.
Okay, so pivoting off that idea of the role of social media in science comms and how that will change in the future, what are the different roles of individuals versus institutions and the role that they play in science communication? Maree, did you want to kick us off there?
Yeah, it's a really interesting question, because without doubt, it does rely very much upon an individual. And the mindset of that individual to be willing to do that, and the skills they have to do that, and upskilling them and so forth. But that individual exists within an organisation, and that exists within an institution, the institution of science. And the institution of science is interesting because the way we do science often shapes the practice of science and the assumptions we make about that practice, and also the culture of science. And that leads to the way and influences the way we think as scientists, what knowledge is valuable, what knowledge isn't valuable, and our institutional support to help us to speak more widely. I mean, I talk to a lot of scientists who will often talk about that, yeah, there might be a lot of help to do science communication and to put out their information, but to actually engage with communities is a lot more problematic, because that takes time. And you can't tell a budget that, that's got to be done in 3 years. Well, actually, we've talked well, we engaged in dialogue. So there's the institutional change that needs to go on within it, because this is science communication is a whole of system approach. It starts with the individual, but it's supported by the organisation, and it exists within the culture of science. And I don't think you can adequately separate those within where we're going with science communication in the future.
Brent, you have some experience with this, don't you?
Yes. Look, within a large organisation like Plant and Food, and also with Maree at the university, where the universities and the CRIs, they're blessed to be big enough to have science communicators embedded within their institute. So some people in our organisation don't like communicating. That's fine. And the science communications team can find those who do want to do it and who do enjoy it. So through our large institutions, we can do that. But there's another role that we need, because out in social media in particular, there's a lot of misinformation, wrong facts, but even worse than that is disinformation, where there are facts, so-called facts put out with the intent to mislead. So we do need to counter those with information. And the Royal Society Te Apārangi has New Zealand Science Media Centre, and this provides an access point to access general science across New Zealand, and it's performed very well through the COVID crisis, through Whakaari White Island, through the Christchurch earthquakes, in terms of getting information out there that the public needs to know, and that is verifiable, evidence-based, and neither disinformation or misinformation. And both of those are called out, especially disinformation, which is more common these days.
So can I put a challenge to you then? Because the challenge is, in fact, I went to a science communication conference online just recently, and the question was, should we trust scientists?
Yes.
Should we trust scientists? Why? How do we know that information? Do we just trust you because you're a scientist? And one of the science communicators, who's regarded around the world, highly regarded as a science communicator, she turned around and she said, why should we trust scientists? She said, if we aren't questioned, If there isn't questioning of what even we say, then there's something fundamentally wrong. It's good to be questioned. Now, of course, you've got to separate disinformation from misinformation without doubt. So what we have to take a responsibility as scientists to do is to actually build up criticality in communities so they can actually decipher between what is disinformation, what is misinformation. And then we as scientists also have to say, what do we need to be questioned on? So there's a role for all of us to play in this space. And in an education institution like I am, I take it a significant responsibility to be involved in increasing criticality in the wider population as well as within the student base.
Yeah, that's a very good point, Maree, and that goes back to my earlier comment about serving as an expert witness in court. You give your expert opinion, and that is established. The beauty about the court system is that, one, sort of beauty in inverted commas, it's adversarial, so the opposing any given expert witness, there will be another expert. The beauty is, however, there is a judge who will make that decision. And so what we're trying to do here, I think what you're saying, Maree, is that we have to use scientists, and the Science Media Centre never just uses one scientist, they get a range of scientists. And so the public can judge the factual basis of what's being presented.
I think the media and social media and society in general it's a very complicated place. But if we've learned nothing through the pandemic, it's that anyone who has a public profile is adequately educated in every topic, shall we say. For some people, they will always believe the person in front of them over the person who is not in front of them, like a scientist. So they would much rather believe their social media influencers, which is a horrific word, but they would much rather believe them if they have no knowledge whatsoever on some of these topics, but they're telling them something and they believe it wholeheartedly because they feel they have a personal connection to this person. And then a scientist pops up out of nowhere, says, no, that's wrong, and then pops back into their room. So this is where we get back to we need scientist rock stars so that people see them as a source of truth. And yes, they can be questioned. But wouldn't it be nice if people questioned the social media influencers once in a while without being told off and being told that, you should just believe them absolutely because they're famous. And the media has a role to play as well, because the media like to say they present a balanced argument sometimes, but their version of a balanced argument is, and we've seen this with climate change, and this will be something close to Brent's heart, I'm sure, where a balanced argument in the media is a person who is a climate change advocate, for want of a better word, and the other person is a climate change denier. An equal weight is put onto those two people, despite the fact that there might be 100 scientists, 99 people are saying one thing and one person is saying the other. The way the media balances it is by going, well, here are two views, and they hold equal weight. And so there's some big old problems out there that are really complex, and science can solve them. But without the trust in science and scientists, I think we're just on a merry-go-round of false news, misinformation, disinformation, influencers, people who don't know what they're talking about just rising to the top, while the people who do know what they're talking about sort of disappear into the ether. It's concerning as a nation, as a global it's a global
phenomenon.
Even.
Yes, it is, and it's very disquieting.
And I don't. There's not going to be one thing that breaks that, because if it had been one thing, I think it would have been the pandemic.
I think this is where representation comes into it as well, because scientists have historically been viewed as, men in white coats hidden away in a lab that we kind of hear from every now and then, but we don't really see them much. And influencers, on the other hand, are in your face 24/7, and people build relationships and connections with them. So I think it's the role of the scientist to reinvent that public image of what a scientist is, make those partnerships and those connections with the community, make sure that the trust is there, make sure that the communication is there in the first place. And then we'll have those open discussions where people actually begin to not only, trust what we're saying, but also believing it as well.
But also recognizing that for scientists, that theirs is not the only voice.
Of course.
These things are complex problems. So science will not solve climate change alone. Won't. Okay. No. It requires politics, it requires policy, it requires communities, it requires Indigenous communities, it requires all these things. Science is an incredibly important input, but it is just one input and into these things. So it will not alone be able to do this.
And that goes back to my favorite quote, which is all good science is not done in isolation. And that doesn't mean just scientists working together, that's society working together.
Absolutely. How you work with society is the challenge.
On that, I'm curious from some of you who have more experience with this, some of the challenges that exist on that front. One of them is most scientists that I know are completely focused on accuracy. So that's sort of one of the well-known issues we have in that dichotomous, that false debate that Emma was mentioning, is that the climate scientists, our results always include a degree of understanding how likely we are to be wrong. That's what we seek to be correct by understanding what our margin of error is. And so most scientists really struggle with coming out and saying something is absolutely going to be true in the future, because it's the future. We don't know. Whereas the person on the other side of the table who isn't constraining themselves to the same sort of standard of accuracy can say whatever they want with whatever level of certainty they want. And it's kind of connected to, a broader thing where the process of science, one of the sort of core assumptions is that we have a shared reality. And I think science is on this point where we're starting to recognize that I guess we sort of touched on it earlier, that there's not just one concern that's sort of pushing a what we would call an anti-science view, and that to really convince those people of our science who have received the message and rejected it, we really need to understand what their reality is. And I guess I've not figured this out. I'm wondering if anyone else has any.
I think social scientists. You need social scientists. I'll do the plug for social science. Okay.
Maybe I think the one of the problems you've sort of highlighted there, Brian, goes back to President Harry Truman, who said, "I want a one-armed economist. In that way, he can't say, on the other hand."
But I think it comes to the point you made earlier, Brian, around raising people's knowledge levels and their critical thinking. And if they can understand that when a scientist says, we believe this happens, that actually that's as close as you're going to get to 100% knowledge that happens, then they'll actually listen to the bit after and not just they've just got a belief.
But if the reason they didn't take the vaccine was because they don't trust government, and because of, colonisation and things that have made huge disparities and inequities, it doesn't matter how much you tell them that the vaccine is good for you. You've got a fundamental issue there that needs to be resolved, or needs to be addressed, or needs to be listened to, and needs to be a different way of doing it. We need to change the way we do it. So in that instance, you would use completely different providers and build relationships through different providers than through a government agency. So these are some of the things. Some of the ones, things that we're going to do in the climate change space are going to have to be recognising different people's realities. Brian's totally right there. And those are the drivers that drive people's behaviours and their practices. And we've got to get our heads around that rather than just say, we've just got to change their behaviour. We've got to understand what drives those practices and those behaviours.
Your work is cut out for you. And the clock is ticking.
All of us.
I know. I'm creating I've created a job.
Yeah. But it is human nature. I think we all at some point have dug our heels in because somebody says we have to do something and you just go, I don't want to do it just because you said so. I was going to do it before you said so. Or, human nature is complex enough without adding complexities of scientific based problems on top of that. So
people
don't only do what we can.
People don't use the cleaning stations sometimes at the Curry Dieback cleaning station, even though we know that that's whatever. They don't use it, not because they don't believe in the cleaning station. The purpose for the reason for the being at the forest is not necessarily to get an experience, say, with Kari, it's to take their dog for a walk. So their motivation for being there is completely different. So how can we recognise that and interact with that in some way? And in fact, that's some research we're doing at the moment, and through a co-design process. There you go.
I'm hopeful that Erin's on track to be the rock star that Emma's talking about. She's got the communication background and the solid grounding in science, and people are just going to believe her.
I hope so too. That'd be nice.
No pressure.
Hey, with that being said, I think that's a great point to leave the listeners with. We'll end there for today. But how exciting is the future of science comms? And we've come so far over the past, decade to communicate our science better. And we've sort of pinpointed areas where we as scientists have room to improve. And it's really cool to see the work that a lot of you are doing to make those improvements for maybe the next decade coming ahead. So with that being said, thank you so much to all of our panelists for joining us today. It's been a really interesting conversation, and I feel very inspired to get out there and be the rock star science comms that I believe I can be. But also thank you to you out there for listening. Please check out our SIGEST pages on our Plant and Food website for extra links and photos on the topics covered today. Also, please subscribe to our channel on iTunes or your favourite podcast provider, and don't forget to post a review and rate this podcast. See you next time.